Hello and welcome to the November 2021 edition of No Diagnostic Required, a monthly look at what's happening in the C++ community. With me, Phil Nash, and my co-host, Anastasia Kozakova. How are you doing this month, Anastasia?
Good. Trying to recover from the releases time, so playing with some advanced calendars. What about you?
I'm sure we'll get to those releases a bit later. I've been not so much playing with advent calendars as maybe event calendars, as events start to pick up again, and I've just come back from one in person, actually. So it's been a bit busy lately, but I think it's been busy for everyone as we get to the end of the year. Everything's all happening before it dies down, so hoping for a bit of a rest soon. I'm sure you are too.
Yeah, same for me.
So we've got quite a few things to get through again this month. So let's get started by talking about Arthur Dwyer's post. You put this one in, so do you want to tell us about these 3 reasons for passing to string view by value?
Yeah, that's actually a nice post by Arthur. So he's discussing these 3 performance benefits of passing by value over passing by reference or const reference. And actually, the thing is that while it's kind of obvious for cheap types like integer, or you have, a pair of integers, or you have a char pointer. So it might be not that maybe obvious for some other types, which are actually behaves the same like string view, which is the point for the discussion here in the blog post. So the performance benefits are kind of, obvious and stated here, like pass by value eliminates a load from memory for trivial types that are passed in registers and not via the stack. So pass by reference works via the addresses, so the caller has to actually spill it onto the stack. So pass by value can sometimes eliminate the need for a stack frame in the caller, and pass by value provides caller with a greater number of optimization options, while the reference to the unknown object forces the compiler to behave more conservatively, probably. Like the performance cost of making a copy outweighs, if actually the performance cost of making a copy outweighs all of these 3 benefits, then that's good to know about it. There was an interesting follow-up to this blog post, which actually took my note, was that there was a discussion under the blog post, which was raised in response to this blog post, that for Microsoft x86-64 ABI, it does not pass to string view in registers. So that's not always true, actually. So the reasons Arthur was listed there is not always the case. But for the rest, that's true, and that's good reasons to pass it by value. But there are cases when that's not true and the string view is not passed by registers. So actually there is some exceptions to the case. So that was a nice follow-up. And I guess that's always what I appreciate under the Arthur post is the, all these discussions with the corner cases. And that's actually not a real corner case. It's just the regular, platform and the regular architecture you might be working with. So that actually captured my attention. So what do you think about it, Phil?
Yeah, I was quite surprised about that not being passed in registers on. It's just the x64 version of the Microsoft compiler, he said. But yeah, still quite surprising. But he does make the point that it's still preferable to pass by value, even if you know that's going to be your target. That is one of the things I like about a lot of Arthur's posts. I know we feature them a lot, because he does often pick things that seem obvious, or, I know that. And then he goes much deeper, and you think, I didn't know that.
Yeah, that's true. That's true. That's what I appreciate him either. Yeah.
Yep. Always a good deep dive. Okay, so moving quickly on. So we've got a lot to get through. So Vector of Ball talks about Catch 2 version 3.
Yeah, you probably have heard about this framework for unit testing, Phil.
I've heard of it. I've actually not really had any involvement in the development of the version 3. And the big push with version 3, which is relevant to this post, is that rather than being a single header framework, as it's always been from the start, it's now been split out into separate CPP files. You can build it as a library. And that makes a lot of sense in some ways. A lot of people have expressed concern myself included, that actually may hurt adoption because that's been one of its major selling points, that it's so simple just to drop in a header file. But there's some nuances and things you've got to get right the other way as well. So it's not quite as clear cut as that. But regardless of that, Vector of Ball's position here is, well, let's make that as simple as possible. So he's talking about using these tools, DDS and PMM. Do you want to tell us about that?
Yeah, that's a very short but very practical blog post, which demonstrates a nice scheme of how you can use the libraries like Catch to version 3 with CMake via these, two nice abbreviations. So DDS is a drop dead simple, and PMM, it's not my job position. It's the package manager. It's actually just a simple CMake, which you can include, and then it just, the CMake script, it manages external packaging tools. So right now it supports like the Conan and VC package and also DDS as shown here. And it automatically downloads, installs, and controls package managers from within your CMake project. And that's actually what the author is doing here. So you're actually using this Catch2 and DDS via this, simple PMM CMake script. And so, you're done in just a couple of lines. So that's as simple as just, including a catch header as it was before when it was a header-only framework. So, yeah, I think that works. And moreover, I started thinking about, if we can utilize maybe the PMM somehow in the IDEs, because it looks like a nice way to cover all package managers at once. That's just a rough word. That's not a promise. I haven't even discussed that with the team, but it looks promising. I mean, if it could work with all the known package managers, maybe that's what we need, not, just supporting all of them one by one, but using something more general. And that's not just because I like the abbreviation here.
Yeah, the big problem I had with this post was I wasn't sure whether to go with a yo-dog joke. How do you like package managers? So we made a package manager for your package managers, or just go simply with who manages the package managers. So either of those will do, but it all gets a bit meta. But if it solves the problem, then why not?
Yeah, but maybe the PMM as a package manager is fine for CMake, which is a meta build system. So they're kind of on the same level.
Yeah. Okay, well, let's look at something that's a bit less ugly now. New book, Beautiful C++. What do you want to tell us about this one?
Yeah, first of all, that's a beautiful book, and it's about beautiful C++, and I really like it. So I've heard about it before when it was still in progress from Bjarne and Herb while I was discussing the C++ core guidelines with them. And they told me oh, and by the way, the guy and Kate, they're writing a book about the core guidelines. And I think these are the, awesome candidates for that kind of book. So Kate actually had a great talk at CPPCon several years ago about 10 core guidelines you can't miss. So it was kind of expanded to 30 by Guy, and he brought more examples and some detailed explanations to the very practical use cases and how you actually should use them. So, and there are a very nice forward and afterword by Bjarne and Herb about the book and what they think about it. So what's the emphasis there, how you can find the benefits out of it. And I think that's a very good practical start if you would really like to start with the C++ core guidelines. And that's the thing you can't miss these days. So that's a very good, collection of recipes, but you need to know how to apply them. You need to know how to work with them. And looking at these, nice examples in the book. So it's not already published, so it's available for the pre-order, and it's planned for the end of December. So maybe that's, a nice present for yourself for the new year or for your friend or colleague. So the only thing, I'm feeling sad about is that I'm not going to read it in paper probably, and my Kindle Paperwhite probably won't show me this beautiful C++ cover. But apart from that, I think the book is great, and it should be great. I'm pretty much sure about that. And I really like, I'm a big fan of Kate's talk and Guy's talk. So I'm pretty much sure that the combination of those people together in a book should be, an awesome masterpiece. So yeah, waiting for it impatiently. What about you?
I think this is definitely one to get in hardcover. rather than on your Kindle.
Can I get just the cover?
And I'm not sure when people talk about the Beautiful C++ book, whether they mean it's a book about Beautiful C++ or a C++ book that happens to be beautiful. It could be both. I definitely agree that, the core guidelines themselves are something that every C++ developer should be aware of. And of course, as we both know, there are some good tools out there to help you along the way. But yeah, just getting to know the ones that are really going to help you to make your code clean, safe, and fast. That is really going to be a big investment of time that's going to be worthwhile. So having a book that's also easy on the eyes to look at will help you get there.
That's true. I also actually like looking at it from the perspective of a very, practical aspect. We were recently discussing the core guidelines with the ReSharper C++ team, trying to somehow rethink them to understand what was behind the core guidelines. And we wrote a huge document. We sent it to the core guidelines editors for the comments because we're looking for the feedback. I think the book is something we would be very interested in, like reading and looking for, another opinion on the core guidelines at least.
Yeah. And just to be clear, I've not actually looked into the book. I don't know even which core guidelines they're highlighting. But like you, I trust Kate and Guy to do an excellent job of figuring out the right ones.
Exactly. Exactly.
And we definitely need it, given what's going into the standards. So let's have a quick look at our standards news. This month, I'm trying to keep it brief, and I always say this, but that we tend to run long, but try to keep it brief this month by just concentrating on the new or revised proposals that relate to contracts. We mentioned them quite a few times recently. We're sort of quite keen to see them get into, be nice if they get into C++ 23. Well, we may have missed that opportunity now, but we definitely have an interest in it. So the one we've been looking at quite a lot is minimal contract support, either no eval or eval and abort. Now, this one has had a little bit of a revision. Partly it's noted that there is a way you can get infinite recursion if you're checking features that are specified between two objects in terms of each other. So, one has a contract about another, and that one has a contract back about the first one. There is actually a way to get an infinite recursion in there that just hasn't really been discussed before, so that's been added to the paper. And then there's a new section on the syntax between the attribute-like syntax that's been discussed up until now in this paper, and non-attribute alternatives. So we did look at a new proposal, and we'll look at it again actually, proposing a non-attribute based syntax. And now that's been acknowledged in this paper as well. And then finally, there's the difference between two models for the semantics of elision of contract checking. And what that means is if you specify a contract at one point, and then maybe you call onto another function, passing the same arguments, and it has its own contract that's basically identical, then if it's actually checking them, it would seem a bit wasteful to recheck the same contract again and again. So the compiler is allowed to note that and say, well, I'm not going to check it again because I've already checked it. So it's going to rely on the second check, which is fine if there's no side effects. But if there are side effects, which is allowed, according to this proposal at least, then that all has to be taken into account. So there's different models for how to handle that are all covered in the paper. So it's given it pretty good coverage. So on the one hand, it's nice to see this filling out so nicely. On the other hand, it's a shame it's filling out so nicely quite so late before we run out of time to get it into C++ 23. But as I said, I think that's looking unlikely at this stage anyway. So let's get this right and make sure we cover all of those pretty important details that are really emerging at this point, I think. Do you have any thoughts on that, Anastasia?
Yeah, I actually mentioned two things which I really felt a little bit scared about. First is the recursion, because every time we start thinking about this kind of recursions in this kind of features, I feel scared. That's probably the same level of scaredness which I have about, memory allocation at compile time and all these things, which makes me worried about where we're going with the C++. And yeah, the contract collision and the side effects story also sounds a little bit scary because like we're struggling with the side effects in C++ for a while, I guess. So having them in contracts, isn't it too dangerous? Should we just, stop it, make it illegal? Is there any practical use case for having the side effects in the contracts?
There are. It gets subtle. It's covered in the paper, and it's been discussed a lot.
Okay.
There are people that are against it that would prefer to say no side effects allowed. I think the main thing, if I remember rightly, the reason for allowing it is that it's just so difficult to say that it's not allowed. How do you guarantee that? How do you specify that? You can do, but then you limit other things. So, think about ConsExpra. At least until recently, ConsExpra also has that guarantee that that there are no side effects. But that's at the cost of limiting certain other things. And in fact, now ConsExpra can actually have side effects if you're dealing with memory and that sort of thing. So, by removing those limitations, you remove that guarantee as well. So I think that's the main reason. But I think there were some actual use cases as well. Maybe something to do with logging or something like that. But yeah, it's mostly just because it's so difficult to specify it without it. And we have a precedent for this sort of thing where we want to treat it as if there are no side effects, but also allow them, which is the constructor elision. So if you have copy constructors that look like they're being called, but because of something like return value optimization, they're not, then we should expect that to happen, that the constructor would expect to get called doesn't. So if there's any side effects there, then obviously they're not going to occur. And I've been bitten by that in Catch, actually. It was written in such a way that because every compiler I'd ever used elided the copy constructor, I sort of wrote around it as if it wasn't there. And then one day it hit a case where it did actually kick in and everything went wrong. But
yeah, like I just mean because when you have something in the language which you can use, you definitely can abuse it. I mean, like you can use it in a wrong way. Yeah. So the side effects, that's the biggest story for me in this direction. So you can use them smartly and nicely, and they can serve some good goal, and they can really help you, but you can also abuse them greatly. And so the contracts themselves, not the probably, easiest feature in terms of building it right now and allowing all these things looks a little bit scary to me. But yeah, maybe it's fine. Maybe there is a whole bunch of use cases for that.
Yeah. So moving on, but still talking about contracts. Again, the other paper that we talked about last month as well, closure-based syntax for contracts. So this was the alternate syntax where rather than looking like attributes, it looks like lambdas instead. We talked about that in some depth last month. There's a new revision this month. It's actually quite a big revision, taken on board lots of the feedback that the authors have received. A lot of it's actually removing things, like removing some of the syntaxes that didn't seem to be getting a lot of support. It's really just polishing off the paper, getting it into good shape as it actually hits people discussing it. The process that most people's papers go through. And it shows that it's actually getting a lot of interest and a lot of attention, so that's a good sign. It's also clarified the purpose, that it's actually the reason for selecting this particular syntax is it opens up possibilities for future extension that might otherwise have been closed off, and I think we discussed that a bit last month, but that's an explicit intent of the paper. And then we have the predicate elision that we mentioned in context of the previous paper. Has a big section in here, and specifically, one of the things it differentiates itself with is that elision has to be all or nothing. So either a whole expression is elided, or it's not elided. Whereas the other paper, I believe, allows sub-expressions to be elided. So if you've got a compound expression, only part of it that's repeating can be removed. So I think this is just about simplifying the expectations, because you can always expand on that later. But But those are the main things that I noted, at least, that were different in this paper. And then lots of little details as well. That's mostly just seeing it go through the process and continuing to get some attention. I don't know if you have anything else to say about that.
Not really a comment on the paper itself, but I'm just looking at it as a good progress with the contracts, because discussing the syntax means that we're more or less agree on the major goal, hopefully.
Well, yeah, that would be nice.
Yeah, I know. Still, there are details, but and lots of discussions. I understand that, but it's good that we are actually at this point, probably.
There is a paper we'll discuss in a moment that may actually say more about that. But before we get there, since this paper we've just been talking about is about the alternate syntax, the closure-based syntax, there's now a new paper which specifically is discussing the attribute-like syntax. So just drilling into that a bit more, and the discussion around why that might be a choice, how it differs from actual attributes, and why that could actually be a good thing. But it also drills into a few misunderstood definitions. For example, what it means to be ignorable, which is something that often comes up in conversation, particularly when presented with the attribute-like syntax, because there's this idea that, if it's an attribute, then it must be ignorable. And we don't like contracts having this attribute-like syntax because it's not ignorable. And then other people are saying, but we like it having this syntax because it's ignorable. And it's clear that people have different understanding of what ignorable actually means. And I think it mostly comes down to whether the code within the square brackets actually has to be parsed in the case that it's being ignored. So does ignorable mean it doesn't even have to compile, or does it mean it has to be legal code that has to compile and parse, but it's just not evaluated? So it just clarifies some of the terminology around that. Also points out that the standard itself is a little bit unclear on this, and that's probably worth clearing up just in its own right. So again, it's digging a little bit into the weeds, but these are all important weeds when it comes to the discussion of contracts. It turns out this is what we've really been discovering. So good that we're getting this sorted out, and the discussions are being had. But it's just more housekeeping, really, I think. Anything to say on that one?
To me, ignorable is something more or less clear, but maybe I'm wrong here. So having the code which doesn't parse correctly looks like a nightmare. Who would need that? But maybe again, I'm missing the cases. So, but yeah, it's interesting discussions we're running into that. Maybe we'll find something new inside our C++ language with all of this. I'm not sure how the contracts are actually affecting the other papers. If we, for example, dig for some new issues in the current language features with the contracts, it looks like this might happen.
Yeah, something you mentioned just now about ignorable and whether actually being unparsable is useful reminds me of another article which I was going to put in to our list, but I was trying to keep it pared down, so I didn't, but maybe I'll throw it into the notes. New blog post by Barry Revzin about conditional compilation and the different models for that. And one of the points he makes is that there are cases where you don't want things to be, I forget the specific terms now, you have to be really precise with these things, but it gives the example of, say, a smart pointer, where you want to have a dereference operator, but you don't want the dereference operator if your smart pointer is on a void type, because it's going to be illegal. Now, if you use concepts to try to disable the dereferencing operator, it will make it not visible, but it still has to compile, and so you still get a compile error in that case. So you can't actually use that technique. So you have to use something else that doesn't even present it to the compiler at a certain level. So that's where I struggle to remember the specific terminology, but there are these subtle differences in what that really means that we really need to be precise about. And that's the problem, really. Just being precise about what we mean. And this is one of those cases where that precision is just not obvious from the wording. So that's really what we're clearing up. It's not necessarily about anything goes. It's about exactly how much does go, I think.
Okay.
Okay, so the last one to look at that's related to contracts, but it's actually not contracts, and that's kind of the point. Portable assumptions. So one of the things that was in contracts in C++20 was this idea of an assumption. And an assumption is a hint to the compiler that it can make assumptions because this thing will always be true or never be true. And then the compiler can optimize around that. So it's really useful. And when it was proposed, people said, oh, that should be in contracts. So it was rolled in. And that was one of the things that created tensions and problems because not everyone agreed with that. And it caused things like the time travel, undefined behavior, causing things that seem to be unrelated happening. All those fun things that we've talked about in the past, many of those are related to assumptions being part of the contracts specification. So they're not in the new contracts papers, which gives freedom for this paper to come back. And in fact, it was being discussed in Prague in early 2020, so before everything started to shut down, the last physical standards meeting. It was doing pretty well, very well received. So Timon, who has just joined JetBrains as it happens, went off and responded to all of the questions and commentary in the meeting, put together the next version that was almost sort of greenlit to sail through from that point. There's a little bit of dissent, but not very much. In a very good position. Then the pandemic happened. Everything got off track. So this paper has only just really been revived again. It's just been dusted off and tweaked a bit and updated to accommodate things that may have happened in the meantime, and been presented back again. It's gone through EWG, and that they are saying now it's ready for polling. Hopefully then gone to CWG, the core wording group, for wording review, with the aim of actually getting in front of plenary where the final vote happens before the C++23 cutoff. So this may be a part of what was in C++20 contracts, effectively, that does make it into C++23, which on its own is great news because this is a really useful feature, as we said. But it also means that the other contract papers are sort of free from having to worry about that even in the future, potentially, if it's already in the standard in another form. So if it's like a double dose of good news that this is moving forwards at this point. So any thoughts on that?
Yeah, I'm just sitting here wondering if it's indeed better to have as a separate or as part of a contract. So what are the drawbacks? So what are the pros and cons of this decision? I mean, like if contracts were planning it for a while, so I think they have some coherent decision for it. But like I'm not sure like if contracts themselves are now something coherent with all the papers we're still discussing around the contracts, but is it really better to pass this separately, or maybe it was better to, I don't know, still make it a part of a contract? So what are the reasons to have it separate, apart from the fact like that it seems to go first?
So there's not agreement that it belongs as part of contracts. There are strong voices both ways, I think is about as much as I can say. But there are reasons for that as well. It really depends on where you're coming from, what your view of what contracts are in the first place. And that was the whole thing that got thrown up in the air. And let's go back and try to establish what we mean by contracts. And it turns out that the only commonality that we sort of get across all parties doesn't include assumptions as part of that. You can certainly see why they were considered to be part of it, because you're sort of using the same sort of terminology, like this is something that should never happen. And if this is something that should never happen, you can optimize around it. So you can see that. But they're also slightly different, and there are consequences to mixing them. And that's where some of these time travel things come in. Trying to think of a good example off the top of my head now, but I remember there were things where you can have something that a contract that's ignored, but treated by the compiler as a path for optimization, then says, well, because this can never happen, then the thing just before it that we do actually check can never happen either. And so it actually removes a check, a runtime check. So your contracts become weaker because of the assumption being made by the compiler. I'm not doing that justice. I think we talked about it sometime earlier this year in a little bit more detail. But you definitely get these really weird problems. And that's just one of the consequences of it. There have been others that have been put forward that, if you're not thinking about this the right way, it just does not work as you would expect. So I think I'm coming around to this idea that it does make sense to have them separate. And I think that's the only way we're going to be able to get these features into the language anyway, is by keeping them separate. At worst, it just means there's going to be a little bit more repetition, where you're going to say, here's a contract to say this won't happen, and here's an assumption based on that not happening. We have those sort of repetitions in other parts of the language. They're not ideal, but in this case, I think it serves a real purpose. So
yeah,
it is what it is.
I'm just mostly worrying about the consistency of these things. Like if we get these assumptions and then we get the contracts, and if there is something similar, so how consistent they are. So, but maybe I could ask Timo, to write a blog post explaining the position.
yeah. I mean, he'll do it more justice than me. As the author of that paper.
Yeah.
It has been much more central to the contracts discussion as well. But I thought I had another point, but I assume I've forgotten it at this point.
Okay, never mind.
Let's move on anyway. We're already starting to to run long, and we've only got through the bit that I said we'll cut short. So we looked at that. Let's move on to tools news then, because I think this is going to be the big section. But starting with Visual Studio 2022. That's now available. What do you want to tell us about this?
Yeah, like Microsoft announced the general availability for Visual Studio 2022, and I think it has some big things and some reasonable things as well. So the first big thing is probably the 64-bit. So Visual Studio 2022 is, I would say, finally 64-bit, which is good because, like, if you have a huge project, you definitely need more resources for your IDE to work with. And that also means that, like, the resharper on top of Visual Studio will feel better. So, but actually, so 64-bit makes the life of those who have the huge code bases definitely easier. So another big thing, we actually discussed it in July, I guess, in NDR, is the hot reload. Which Visual Studio delivered for C# and C++. So it's like available to native C++ applications when running under the debugger. And so that means that you can actually make the changes without, restarting the whole process when you're debugging. So just apply them on the fly, which is great, I think, for the short loop of the debugging. So, and we actually discussed it earlier, so I won't dive deeper. And there are lots of other highlights, which are like smaller but also meaningful, which definitely makes sense. Like you can now build and debug natively on WSL2 without establishing an SSH connection, which is a nice performance improvement, I guess. It has enhanced support for CMake presets. So the CMake presets are actually actively developed by Microsoft and Kitware. I guess that's a nice collaboration. So there is like a whole community affecting them. That's definitely because like that's all kind of open source, but Microsoft definitely does a great job on enhancing them, and they are like right now working on the proper support, so trying to tune their support for the latest changes. So they also added the remote debug with LDB from Visual Studio, so you can do that right now. And they added support for lip fuzzer, so under the switch fsanitize fuzzer, so which is a nice fuzzing library. And they improved some code analysis and IntelliSense, and especially they mentioned the Unreal Engine codes. So they did some work in that direction too, which is nice because for a very, very long time, I haven't seen any activity from Visual Studio in the direction of the Unreal Engine, which is kind of an interesting framework and a big, game dev segment. So we do our job on our side with our tools, and I was always wondering if Visual Studio is planning to do more, and seems like they're coming to this playground, so which is great. So it's good to see that the tooling evolves for Unreal Engine developers, so it's not just the plain C++ tooling, but something better, kind of. Yeah. So it seems like a huge release. So wondering, what are your first, Phil? Do you find something interesting, or maybe you have some nice additions here?
So a lot of it sounded familiar, and I think it's because we've been discussing some of these things while it's in beta, particularly the 64-bit. I know we discussed that last month. And for me, that's still outstanding, the big one, because for so many years we've been asking, why is it only 32-bit? And finally, they have responded, and I'm sure that's a huge undertaking on the inside to make that happen. So I'm not going to say anything against them for taking so long, but it's definitely a big finally on that. The other things I have less sort of an opinion on. It's been a few years now since I was actively developing with Visual Studio, so I'm not quite up on the state of the art, but great that it's still being so seriously worked on as a first-class development environment. That's what we need. So I'll leave it there, I think. Although what I will say is that, so it was released November the 8th, that's the actual release date.
Yeah.
And on the day, SonarSource had support in SonarLint for the new Visual Studio out of the box. So I think that's worth mentioning if you do use SonarLint. So version 5 just been released with support for VS 2022. Making full use of that 64-bit address space. Not much more to say about that other than the fact that it also drops support for Visual Studio 2015. And that makes me feel old, because the last time I was actively developing with Visual Studio, we were just trying to move on to Visual Studio 2015. So yeah, these things do have a habit of speeding up if you're not watching. But definitely time to move on. And I think 2022 is going to be where everyone wants to be. So yeah, anything to say about that?
Yeah, I just want to mention that it's great that the tools which are kind of working on top of Visual Studio are also, coming to release, like approximately the same days. We're actually also going to release ReSharper tools for Visual Studio 2022. I even guess that by the time this episode is live, the release is already live as well. Yep. But that's just a matter of days. Yeah. So it depends on how quick are you with the processing of the episode. Yeah, so it's good to see that the tools are there for Visual Studio. So if you're going to move to the Visual Studio 2022, your tools, if you're using them on top, also like kind of compatible with the newest version. So that's like, you shouldn't wait for them to follow up. Yeah.
Right. Well, I know there's no big announcements on the JetBrains side, so I had to scratch around and find some news there. But maybe I'm kidding, of course. Maybe you want to tell us about the new remote development for JetBrains IDEs.
Yeah, I think we started last week with all these remote development announcements. So we started early on Monday, and it was a whole week dedicated to this remote development topic. But actually, we worked on it for a long while. And that's the reality which is with us for a very long time. I guess it started before the pandemic, when we started realizing that all these remote environments are kind of important. And the pandemic just, pushed it harder on us, that we had to think about it. So all these remote functions and distributed architectures and online collaborations are kind of becoming essential for us, for the developers. So we can't work without them. So in JetBrains, we've been working on this functionality for a while. And last week, we actually opened the preview and beta versions to the general public. So first of all, for all our IntelliJ-based tools, including CLion, like IntelliJ and PyCharm and others, we announced this new remote development support for our IDEs. So, and that's actually like if you worked with remote development in CLion, which is there for a few years, it's kind of, which I now called old remote development. It's not that old, actually, but it's just different. The new remote development assumes that you can host your source code, toolchain, and IDE backend on a remote server. And you can use local thin client based on the IntelliJ platform to, to write, navigate, refactor, debug, and test your project. So do all the stuff. So you have just the local machine with the thin client, and you have the remote machine doing all the job for you. So, and the experience is like working with the project in your JetBrains IDE locally. So this thing is now in beta. So, and in case of CLion, it comes with some specific limitations, which I do mention in the CLion release blog post. So you can check them out. So I'm not going to list them all in detail. So, and we actually keep working on them. So that's the work in progress. So there will be less limitations in the future. So we're going to kind of proceed with excluding them one by one. And like the benefits of the general shim is kind of obvious, I guess. So first of all, it's the security, as you keep your code in a remote server. And that's probably some kind of a secured remote machine with some maybe authorized access or something. So you don't need to actually synchronize your code to the local machine, which was the case for the previous remote development flow supported in CLion. And also, like, you can use some kind of a weak laptop for your thin client. So, and, all the smartness is happening on the remote machine. And that's the, real machine. And you just have, some thin client locally. And you can also prepare the remote environments for your team to, for them to start easy, and you can share them. And in some cases, which is not right now the case for CLion, but we're going to work on that as well, you can even warm them up so that you can start immediately without, waiting for reindexing and all that stuff. That's also kind of, I guess, supported for IntelliJ IDEA and for some others. So we're still working on it for CLion because it has a little bit different architecture in this place, but it will also work in some future. So that's about the remote development. So you can read through the blog post. There is a thing called JetBrains Gateway, which helps with, starting all these things. And you can read our, my instruction in the release blog post about how to start in CLion. So, and it generally works. So if you take like the CMake project, you take the, some unit tests, we actually check that catch is working. So yeah, it will be working. So like debugger, all the things. So there are some things which are still kind of doesn't work as expected. So that's, again, still a work in progress. So it's beta stage, but it's moving there quite nicely. So you can try it out. And I guess there were lots of requests for CLion for these kind of remote developments. So I guess, I hope you can find what you were looking for a very long time. So, and there is one more thing here, which I just want to touch briefly, because that was the part of that announcement, but that's a completely different thing, which I guess many people actually kind of, swapped. There were another tool which we actually started, and that's a new IDE, and it's called Fleet. And if you ask me what is Fleet, so it's a polyglot lightweight editor first, but you can turn it into a full-featured, fully functional IDE with just a single click on a button. Mm-hmm. And it has a completely, reimagined UI, and you can just check a few screenshots in the blog post and on our site. And it actually, why it was kind of combined with all this remote development announcement, because it's built on top of this distributed architecture. So we built it having this remote reality in mind, so that the world is not that it was before, like when you have everything locally. So that was probably the first time in JetBrains when we started an IDE from scratch, completely with this remote idea in mind. And also, yes, we took all our 20 plus years of JetBrains experience to bring all the smartness to the tool. Sad news is that you can't try it right now if you haven't signed in for the preview before, because we've got kind of 130,000 requests to join the preview already. So we closed it for now because the team would like, to review all the feedback carefully. So we are right now allowing people to join the preview slowly going through this, long list of requests. So we kind of closed the public preview. So you still can follow the announcements at jetbrains.com/fleet or in our Twitter, or subscribe for the announcements. There's some form. The good thing is that we're right now working on C++ support for Fleet, and we do hope that the team will be able to deliver some C++ support in Fleet preview in 2022. So you can expect the C++ there. And it seems that it, might have some audience there. I guess there's something about 10% of those who requested the preview who are using C++. So I do expect some audience. But yeah, again, so it's a completely different tool. Do not, mix it with the remote development. Remote development is something you can use right now for your IDE of choice, be it like CLion, IntelliJ, or PyCharm or whatever. Fleet is something which is for the future. But if you're interested, just follow the announcements. I don't know, Phil. Did you actually manage to get into the preview, or you missed the announcement?
I missed the announcement. The first I heard was when I was at a conference last week with some former colleagues who mentioned that it had finally been announced. Because I obviously heard about all this from the inside when I was still at JetBrains, but couldn't say anything before. So I'm quite excited that it's all been announced now, both tools. But I haven't had a chance to play with it myself yet. We'll do that. If I can't do it soon, I'll just have to wait. But no preferential treatment for me.
Okay. But you can try the remote development right now.
Oh, yes. Yeah. But if that's the future of JetBrains tools, we still have the present, which is even more up to date than it has been before. So there's a new CLion as ever. So you're going to tell us about 2021.3.
Yeah, I actually already mentioned that blog post while talking about remote development. So that's exactly the place where you can find the, some CLion instructions and limitations for the remote development. But 2021.3 release is much more than just the remote development. So that's the third major release this year. And it has actually lots of improvements in CLion toolchains. So there's lots of updates. So we kind of added the new Docker toolchain so that you can work with Docker easily, not like using the remote toolchain for that, but the special dedicated Docker toolchain. It actually adds some nice goodies for Windows users. We finally decided to bundle the MinGW on Windows. So just to make the startup easier for those who are just starting with CLion in, kind of empty environment without any compiler install, so that they don't have to install plenty of tools before starting with CLion. We also bundled Ninja on all the platforms because it seems to us that it's right now one of the most popular modern generator in CMake. And we even pushed it for newly opened and newly created projects in CLion in case they're used locally. So the Ninja generator will be used by default for you. So it's still not the case for remote toolchain because remote environment might miss Ninja. So we want to make sure that your, CMake loading won't fail so that you can actually open the project in CLion. So we're just pushing it locally where we have the bundled version. Also, we added this kind of thing like custom compiler, which is probably the most useful for those who are doing embedded development. Because if you're working with some compiler which is not natively supported by CLion, before this release, you actually could do nothing, unfortunately, because you could either, wrap your compiler with something GCC-like and try to pretend that that compiler is a GCC for CLion, but actually it's not quite often. So right now you can just, write a simple YAML file describing your compiler defines, and then say, okay, CLion, use my custom compiler. These are the compiler defines. And the good thing is that we actually started the GitHub repository on JetBrains and the JetBrains GitHub account, where we are now collecting the YAML files for the most known embedded compilers. And I guess we added something about 10 popular compilers there. There you can find quite a lot. And we're very open to any pull request. Just read the disclaimer carefully so that you don't abuse any legal agreements with your compiler, because quite many of these compilers are proprietary. But anyway, so we are open to accept your request, your pull requests with the YAML files for some known compilers. So let's make this database bigger so you can use these compilers. And there are also project examples, so you can actually take the project example from this GitHub repo, and you can take the compiler description file and you can play with it in CLion. And the last, probably but not the least thing about the toolchains is that we finally added this ability to source the environment with a script. So you can just now point the script in the toolchain settings, and this script will be sourced while using this toolchain in CLion, which is quite useful for, again, quite many embedded compilers who are relying on that. And it seems that you can even use the Intel LLVM compiler via this hack. We tested it, but just for a short while, but it seems that it generally works. So I really encourage you to try if you're keen to try with the Intel LLVM, which is the new Intel compiler based on LLVM architecture. And as for the editors, I guess we discussed that previously, so I won't go deeper. So there are these type hints for the deduced types, so which are helpful for the C++ types that may not be, immediately obvious, like the types hidden behind the auto specifiers, or in structured bindings, or in lambda return types. So the type hints just show you these types, and you immediately know them, which is kind of useful. And there's lots of improvements in the debugger for the rendering of the data in the debugger. And there are different settings which you can tune for and customize the way you would like the CLion debugger to render the values in the debugger tool window. So you can find more in the blog post. There are also update to Space plugin and Rust plugin. So if you're a Rust developer, there are lots of goodies for Rust developers in this release. So just check it out. And as usual, the 30-day trial is available. And you can give it a try, play with it, and we're open to any feedback as usual. And we had some nice videos in the blog post. So Timo did a great job of recording some videos. So if you'd like to start, for example, with Windows toolchain or with Docker toolchains, we have some nice video instructions how to do that. So add just a quick video and you will do a quick start, hopefully.
Yeah, Timo's done a great job on those videos. And talking of videos, I see you've been busy trying to invalidate all the debugger videos that I did just before I left with all the new UI there. And the custom compiler support, does that mean I can finally get my Ball and C++ 3.1 disks out again?
Probably. If you can cook a proper YAML file. So I guess so. Maybe we even have something for Borland compilers in the repository. I don't know. So the developers are actually filling the repository with the YAML files with examples quite quickly. So when I started the blog post, it was something about 3 compilers in the list. But now I guess it's more than 10.
Right. Yeah, I think finding a floppy drive reader will be the hard part of that one.
Yeah.
So lots of JetBrains news this month. And despite that, we've actually managed to get through that in a reasonable time. We're coming in under the hour, I think. We do have one more thing to discuss. We have a little and finally. And this is open to interpretation. You could consider this one off by 1 hour, but because this is episode 12, because we actually started in November 2020, and because we sort of got a little bit later, we're now into December 2021. So I think we can declare that a birthday. We've gone a full year, even if it's only 12 episodes. So happy birthday to No Diagnostic Required.
Yeah, so, congratulations, we made it.
And that's it. We're out now. We will be back next month.
I was discussing with my kid today that I'm gonna kind of record a podcast, and he asked how frequently we're recording. I said so we're recording once per month. So, and he was calculating for a while, and I said, so that's 12 episodes for a year. Are you serious? I was yes.
Yeah, but you could serialize each episode and do a few minutes every day.
Yeah.
Maybe we should start distributing it that way. Well, I think before we get any other crazy ideas, we should probably wrap up. And say thanks for listening. And we will be back with you again next month, which will also be next year for the December edition.
Yeah, see you.
See you next time. Bye.
Yeah, bye.